Welcome back to my today's session on question bank discussion and problem solution of Unit 5. Myself Dr. Sayanti Chatterjee, and today I am going to discuss the some question bank problem from Unit 4, and Unit 4 is basically nothing but the magnetostatics. So today we will discuss the question from the force on the magnetostatics and magnetic field. So what is the first problem today we are going to discuss? A circular coil of radius 1.5 cm carries a current of 1.5 ampere. If the coil has number of turns 25 turns, find the field at the center. So we have a circular coil and the radius is 1.5 cm. So we have to convert it into the meter always. So 1.10 to the power minus 2 meter. So what is the number of turns? Number of turns is 25. What is H? From the first we will discuss the Ampere circuital law. According from the Ampere circuital law, we got H is equal to Ni by 2R. From the Bio Savart's law of a circle, the power at the center H is equal to Ni by 2R. So how we can Ni by 2R. So what is B? B is equal to field means flux density B. The relation is B is equal to mu H. So here mu is equal to mu naught H is equal to mu naught Ni by 2R. Mu naught Ni by 2R. Now, what is the value of the N? N value is given as 25 and I value is given as 1.5. So, N is equal to 25, I is equal to 1.5 amps. So, what is the value of the B? B is equal to, and what is the value of mu naught? Mu naught is equal to 4 pi into 10 to the power minus 7. So, the value is 4 pi into 10 to the power minus 7 into 25 into 1.5 amps by 1.5 into 10 to the power minus 2. 1.5 will cancel out. So, this is 100 pi into 10 to the power minus 5 or 100 pi into 10 to the, it is 2R. So 2R. So actually it is Ni by 2 into R. So 100 by 2 means this is 50. So it is 50 pi into 10 to the power minus 5, and the unit of B is Weber per meter square, or we can write it by Tesla. So this is the formula, and what is the value will come? It is coming 1.57 10 to the power minus 5 Tesla. So we are calculating the force, calculating the field at the center. So formula is H by Ni by 2R. We will put the value and we can get the answer. We are moving to our little revision. So first we will revise about the Lorentz force. What is Lorentz force? Lorentz force, that we know whenever there is a current carrying conductor is in a magnetic field or a moving electron in a magnetic field, what will happen? It will experience some force, and the force is equal to Q into E. What is the force? Force, when it will feel two types of force. Number one force is the electric force. Number one force is the electric force, and another two is the magnetic force. One is the magnetic force. So first we will discuss about the electric force. When the electrons is in the there is a current carrying conductor, there will be an intensity, and due to this, if we keep one electron there, it will feel some force, and the force Fe is equal to Q into E. Q is the, what is Q? Q is equal to number of charge. And what is E? E is the electric field intensity. What is E? E is nothing but the electric field intensity. And we get this force from the Coulomb's law. Similarly, if as there is a north pole and south pole, if we think about a DC machine, we are giving the connection to the stator, it will generate some electric field and we will get the electric force. Similarly, in the stator, when current is flowing, it will create some north pole and south pole and as a magnetic field. Now, if we keep on current carrying conductor, it will feel some force, and the magnetic force Fm is equal to Q V cross B. What is B? V is the velocity of the charge. What is B? B is the flux. So, magnetic force, however, acts perpendicular to the velocity. What is the, as this is V cross B, so it is Vb sin theta, and the direction is the in the perpendicular to the Vb plane. This force can never produce work on charge or cannot impart any kinetic energy. So, the Fm is equal to V cross B. So, what is the total force? The total force F is equal to Fe by Fm. What is Fe? Fe is equal to, what is Fe? Fe is equal to Qe, and what is Fm? V cross B. So, if we write this, we are taking the Q outside Q, E cross V cross B, and this force is known as the Lorentz force. So, what is Lorentz force? Lorentz force has the two part. One is the electric force, another one is the magnetic force. QE plus QV cross B is equal to Lorentz force. We can also write its magnitude is UE plus VB sin theta. E plus VB sin theta. So, this is the total value, the equation of a Lorentz force. Now, if we want for the Ampere's law, what is Ampere's law? According to the Ampere's law, magnetic fields are related to the electric current produced in them. So, whenever there is a flow of electric current in a ferromagnetic material, it will turn into magnet, and magnetic fields are related to the electric current. This law specified that the magnetic field is associated with a given current or vice versa. So, these are the Ampere's law. The magnetic field created by an electric current is proportional to the size of the electric current with a constant proportionality equal to the permeability of the free space. And what is Ampere's circuital law? Actually, Ampere's circuital law is a very, very important law. What is Ampere's circuital law? Ampere's circuital law can be written as the line integral of the magnetic field surrounding the closed loop equals to the number of times the algebraic sum of current passing through the loop. Suppose a conductor carries a current I, then this current generates a magnetic field that surrounds the oil. So, if there is a current carrying conductor I, there will be a field surrounded by the current carrying conductor, and according to the Ampere circuital law, if the flux density is H, then we can write integration of H dot dl is equal to I enclosed. Integration of H dot dl is equal to I enclosed. The equation's left hand side describes that if an imaginary path encircles the oil, as I told here, if an imaginary path encircles the current carrying conductor, the magnetic field is added at the every point. Every point we will get some magnetic field. At every point we will get some magnetic field. And what is the direction of the magnetic field? In the tangentially outside. What is the amount of the current? The amount of the current is the adding of the each point's magnetic field. That's why we are taking the integration of a closed path H dot dl, and it is numerically equal to the current encircled by the root included by the I enclosed, the amount of the current flowing in this route. Next, we will discuss about the two long parallel conduction current carrying 100 ampere. If the conductor is separated by 200 mm, find the force per meter of each conductor if the current flow direction is the opposite direction. So current direction means both are opposite direction, means the current is in the attractive type. So there are two long conductors. The distance between them is d. The current I1 is flowing and here the current I2 is flowing. We will first calculate the force I on 1 due to current I2. We have to calculate the force on the 1 due to current I2. When current is flowing in the second, it is a P, this is Q. So when current is flowing in the Q coil, we have to calculate the P due to I2. So what is F12? F12 we can write like this. From the equation we know F is equal to BIL sin theta. We know F12 is equal to BIL sin theta, and if we think about the maximum force, sin theta maximum value is 1. So F12 is equal to BIL. Now, if we want to calculate the F12, we can write for this BI2 into L. We can write BI2 into L. Now, BI1 into L. We are calculating the force on I1 due to I2. So BI1 L. Now B is due to the I2 current. We have to, then what we have to do? We have to calculate the B. So how to calculate the B? We know that from the Ampere's circuital law, we can write integration of H dot dl is equal to I. So what is H? H integration of dl is equal to I. So also we can then write H is equal to H into dl. So it is I told from the Ampere circuital law, it is a circular. So H, the distance between two is the 2 pi d, and what is the amount of the current? The due to the current I2, this is our I2 current. H 2 pi d. What is the d? D is the distance between the two current carrying conductor, and the value is, we got H is equal to 2 pi d. So H is equal to 2 pi d is equal to I2. So what is H? H is equal to 2 pi, current is H is equal to I2 by 2 pi d. What is B then? B is equal to mu H. Mu H means mu I2 by 2 pi d. We got the value of B here. We got the value of B here. So what is we can write the value of F12 now. What is F12? B. Mu I2 by 2 pi d into I1 into L. This is the force. So force per unit length, we can write mu I1 I2 by 2 pi d. If we calculate the F21, it is the F12, same we will get in the case of the F21, force on the second coil due to first coil. So in this problem we will use this formula to calculate the force. So what we got, this is one current carrying conductor and this is one current carrying conductor. The distance between them is d. Both are taking the 100 amps current. Both case current, the amount of current is flowing is 100 ampere. So 100 ampere current is flowing, the distance is d. So we can, and what is the value of d? D is the 200 mm. 200 mm is nothing but the 0.2 meter. So what is the force? Force is equal to, we got mu I1 I2 F by F, force per unit length, here also given the question, force per meter, by 2 pi d. Mu means 4 pi into 10 to the power minus 7. Here currents are flowing in the opposite direction. For the both the force is same, only the direction, only it is an attractive type, it is a repulsive type force. So F 4 pi 10 into 100 by 2 pi into d, 0.2. So pi will cancel out, it is 2. So it is, we can write, and here it comes 10. So 10 into 10 to the power minus 7 into 100 into 100. So we are getting 0.01 Newton per meter. 0.01 Newton per meter. So this is the force for a current carrying conductor whose distance is from the d is equal to 0.2 meter. Now we are moving to the problem 3. What is the problem 3? Two coils A and B have the 800 turns and 1200 turns respectively, have a common magnetic field. So we can think it will behaves like a, this will behaves like a transformer. They have a common magnetic current. If the current is 0.5 amps, the same amount of current is flowing, and what is the value of the current? Current is 0.5 amps. What is the number of turns? This is our A, this is our B. So number of turns of A is given as 800 and number of turns of B is given as 1200. Common a current of 0.5, the current value is given 0.5 amps. Will provide a flux phi, flux value is equal to 3 milliweber. Milliweber means 10 to the power minus 3 Weber. We have to calculate the self-inductance of each. So what is LA? LA is equal to, we know, inductance is equal to N phi by I. N A phi A by IA. What is NA? NA is 800. What is phi A? 3 into 10 to the power minus 3, and this value is 0.5. So it is coming 4.8 Henry. Similarly, we can calculate the LB also. How to calculate the LB? LB can be calculated as NB phi B divided by IB. So what is the number of tons NB? NB is given as 1200. What is the value of the flux? 80% flux is only cutting. So 0.83 into 10 to the power minus 3 divided by 0.5 divided by 0.5, because the current is the common magnetic current. Same amount of current is flowing in the circuit. So what is the value? It is 240. So if we solve, we can get the LV value in Henry. Actually 24 means it will come 5.76 into something. So we can calculate this. Next we have to calculate the mutual inductance. How to calculate the mutual inductance? Mutual inductance K root of LA into LB. What is K? K is the mutual inductance constant, and it will tell how much flux is connecting the both A and B. So what is the value? The value is 0.8 of 4.8 into LV. So if we solve this equation, we can calculate the mutual inductance, and mutual inductance unit is also Henry. So if we calculate this both, we can calculate the LA and LB, and we can solve the both equation. So what is the steps? So if we want to write the steps like the previous problem, what is the steps? First we will take the LA, NA in number of turns of A coils and number of turns of B coils, and we will also calculate the current. So what is the inductance formula? Inductance formula is N phi by I. We are using the same formula, NA phi A by IA and NB phi B by IB. IA is equal to IB, both are equal. After solving the equation, we will get the value of LA and LB. And what is the mutual inductance? Mutual inductance M is equal to K root of LA plus LB. LA value is given, LB value is given. So from there we can calculate the value of the mutual inductance. Now before moving to the question number 4, we will discuss the torque on a magnetic field. You can see that there are, if in a pole, there we can see, here you can see that this is the poles and this is a current carrying conductor. So it is a rotating current carrying conductor, means it can stay in any position. It can stay in any position. We are assuming the length of this coil is, total length of this coil is L, and the distance between the midpoint is W. So W is the distance of the coil from the two ends is W, and the length is given as L. So next we will discuss. So it may go in the, when it is rotating, it may go in the different position. Here we have shown the 4 position: A position, B, C and D. So it, when one coil is rotating, it will go in the different position. So each vertical segment has the length L. So if we think that each vertical segment, the coil has the, each vertical segment has the L, and it is perpendicular to the flux B. So what is the force? Force F is equal to BIL. BIL. We are only taking the highest value, not all the value. BIL. So we know what is torque. Torque is nothing but the force into, or we can write BIL sin theta. So what is this? Force into the distance between two points. what is the W? W is equal to distance between two points. So what is this? This is the torque. The distance between 2 points is nothing but the W. So we can write torque is equal to NIWILB sin theta. So torque is equal to NIAB sin theta. So torque is equal to N. We can write what is if number of turns is N into I A, because L into W, L length into W is nothing but the cross sectional area A, N I A B sin theta. What is B? B is the flux density and theta is the angle. Then what is the maximum value of the force? The N I A B. N I A B is the value of the T max. Now we will use this formula for our next problem. So now we are in our problem number 4. What is in the problem number 4? Problem number 4 tells derive the maximum torque on a square loop of 100 tons in a field of uniform flux density is 1 Weber per meter square. So uniform flux density is 1 is equal to 1 Weber per meter square. The loop has 10 centimeter side and carries a current of 3 ampere. It carries a current of 3 ampere. So it is a square loop. Okay, so what is the total cross sectional area? Cross sectional area is 10 into 10 is equal to 100. So what is the torque? Torque is equal to N B A sin theta. And what is the maximum torque? Torque max is equal to into I. So what is the maximum torque? Maximum torque is N. Here number of tons is given as the 100 tons, 100. What is the value of the I? Current is 3 ampere. So I, NI. What is the value of B? B is the 1 Weber per meter square. What is A? It is the 100 centimeter square. So it will come 100 into 10 to the power minus 4 meter square. So it is 10 to the power minus 2 meter square. So 10 to the power minus 2, this is the maximum value I N B A. So it is coming almost 3 Newton meter. The value of the torque will come in as the 3 Newton meter. What is the magnetic moment of the loop? We know magnetic moment of the loop is the I into A. So what is the value of I? I value is 3. What is the magnetic moment? Magnetic moment value is A value is 10 to the power minus 2. So this value will come as 3 into 10 to the power minus 2 or 0.03 ampere meter square. Ampere meter square. So torque I is equal to NBA sin theta. We are calculating the maximum torque. So torque maximum will be when sin theta is equal to 1. So we can put the value, and if we put the value, we can get 100 into 3 into 1 into 10 to the power minus 3. M is equal to I into A is equal to 0.03 ampere meter square. Next, we will discuss about a self-inductance of a toroid. What is the meaning of a toroid? Toroid is one type of coil on which we are giving some connecting wires. The inner resistance The radius is given as small r, the yellow one is the small r, and the external resistance is capital R. So we have already discussed in my previous section what is the self inductance of a toroid. So if we put the value of B, we can get the toroid is the capital N square mu naught r square by 2r by into Henry. So we are getting the value of the self inductance, that the L is equal to L square. L is equal to N square. N is equal to number of turns. What is N? N is equal to number of turns into mu naught into capital R square. What is capital R? Capital R is this green one, the outer radius, r square by 2r. 2r is the inner radius. So based on this, we will discuss our problem 5. So what is the problem 5 told? A toroidal coil of 500 tons is wound on a steel ring of 0.5 meter. The mean diameter is mean diameter, and the 2 into 10 to the power minus 2 meter square is the cross sectional area. An excitation of 4000 ampere per meter produces a flux density of 1 Tesla. Compute the inductance of the coil. So what is the formula we got in our previous section? That N square mu naught r square by 2r. So if we put the value L is equal to N square is nothing but the 500 square, mu naught, so N square mu naught r square by 2r. So we are getting the value N square mu r square by 2r we got from here. So if we put the value N is equal to 500 square, the steel ring of the 0.5 meter is the capital R, mu we will take as mu naught, and from this cross sectional area means pi r square is equal to 2 into 10 to the power minus 2. So after solving, we will get the value of the R. Remember one thing, that if the outer radius and inner radius is not mentioned in this problem, then the outer radius will be always the bigger one and the inner radius will be the small one. So from there we can calculate the value of R. Next part of the problem is, if a 10 mm long gap is cut in the ring, determine the current required to maintain the flux at 1 Tesla, and also find the inductance at the new condition. So how to calculate these things? For the silicon ring, what is the value of B? B is equal to phi by A. Phi by A is 1. Phi value is given in the problem by A, so it is coming as 1.4 Tesla. So what is H? H, if we can write from the BH curve, and we can get the value of the H. So if we cut the air gap, then what is the value of the H? H value is again from the B by mu naught. B value is the same, 1.4 by mu naught. If we put, we will get the air gap value. So what is the MMF? What is the MMF in the air gap? It is for the total. If we think about the total flux, so what is the MMF? The air gap is the 10 millimeter long gap. So it is 10. 0.01. If we multiply it, we will get the MMF. And if we get the MMF, we can get the flux and we can calculate the inductance. So this is my today's discussion, and thank you. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.